All right, so let's look at side channel. And the first problem is constant time expression. So in the following code, there is a branch dependent on secret A and B. So here, and the secret is being used for conditional branch. So if A and B, then we change the value of J by incrementing it. The question is transform the following code to constant time expression without logic minimization. Okay. So uh, let's solve this problem. So for solving this problem, we create a truth table. Hmm. False, false, true, true, false, true, false, true. And then we, okay, I'm going to leave some room for something else, but later we will revisit it. But for now, J will be assigned what value, right? So by working out the logic of this code, we will figure out, right? So if A is false and B is false, then this will not be executed, meaning that the J value remains the same, or we can say J. If A is false and B is true, then this also will not be executed. So J will not be changed, so it will remain J. If A is true, B is false, again, will not be executed, so J will not change. And finally, if both are true, then this will be executed, meaning that the value of J will be replaced by J plus 1. Is that it? That's the initial step, analyzing this code. And then in step 1 for creating the code. So let me just write it here at the bottom. So we introduce a new secret variable, BA and BB. And this will be obtained by not A and not B. Okay. What's the meaning of the not? So basically, the not will transform. Okay, let me just write it here. BA will be either 1 or 0 if A is not equal to 0, if N will be 0 if A equals to 0. Okay, so basically, it's binarization of the value of A. All right, so that's step 1. And step 2, create the truth table. Okay, wait, let's integrate this. Create a truth table that corresponds to the expression. So here we have BA, BB, and then here is simple. So if you see a 0 for F, false, then here we come 0. So 0, and then true will be 1, 1. And then same for B, false will be 0, true will be 1, false will be 0, true will be 1. Okay. So the next step 2, we create a term that correspond to each of these logic values. Okay, so in this case, term or the product of literals. So the way to do it is basically if you see a 0, you 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 insert a corresponding term, which is 1 minus BA. And if you see a 0, it's the same thing, so 1 minus BB. Okay. Now, so you just replicate it below, so 0, 1. So that means 1 minus BA multiplied by BB. You see 1, 0, that means BA multiplied by 1 minus BB. Finally, 1, 1, meaning that is BA times BB. So that's the term. And then the next is sub-expression. So this will be step 3. Sub-expression is basically just the multiplication of this with the multiplication of this. Okay. So then we will have J times 1 minus BA, 1 minus BB, and then here J times Y minus BA, BB, J times BA times Y minus BB, and here finally is J plus 1 because it's J plus 1 over here times BA times BB. Okay, that's it. So after you finish this, then basically the answer, the final answer will be, the code right here will be changed. It will become J equals to J times, and then we have 3 expressions, so we can just put them together like this. So that's J. And then we add, basically we just add all the sub-expressions. J plus 1, BA, BB. That's it. So all we need to do is to replace the original statement of J with this, and without the if instruction. So the conditional disappears.